Again, good morning. This is Engineer Margisal Rapier, your instructor for Introduction to Differential Equations or to Differential Equations. Ang topic natin ngayon is Introduction to DE. Commonly na-abbreviate yung differential equations sa DE. Yung abbreviate. Acronym pala. Okay, ano nga ba ang isang differential equation? Kahit anong equation na merong derivatives ay matatawag nating differential equation. Kahit ilan pa yung dependent variable dyan, isa, dalawa, tatlo, na nag-change with respect to an independent variable, which is again one or more independent variables, ay matatawag nating differential equation. For example, okay, palitan ko ng white. dy over dx equals 3. This is a differential equation. Meron siyang derivatives, meron siyang dependent variables. Y is a dependent variable, x is the independent variable. Yan. Kapag nakakita na kayo ng dy dx, differential equation na yan. Merong mga types or pwede natin maklasify ang differential equations. Okay, and merong iba't ibang classification yan. Una, sa type, meron tayong tinatawag na ordinary differential equation or ODE. Yung ordinary differential equation, ito yung ordinaryo nga. Yan, kagaya niyan, dy over dx plus 5y equals e raised to x is an example of ordinary differential equation. Yan. This is an example of ordinary differential equation. Ito din, the second derivative of y with respect to x minus the first derivative of y with respect to x plus 6y equals 0, or d squared y over dx squared minus dy over dx plus 6y equals 0. That is again an example of an ordinary differential equations. Si ordinary differential equation, kagaya nung definition natin ng differential equation kanina, pwedeng hindi lang isang dependent variable, pwedeng maraming dependent variable. For example, dy squared, second derivative with respect to t plus, ayan, equals 6. Yan. This is an example of ordinary differential equation with two dependent variables. Mapapansin nyo, yung y and x, yung dependent variable natin, and t is our independent variable. The other type of differential equation is the partial differential equation or PDE. Itong klase ng differential equation na to ay it contains partial derivatives. Kagaya nito. Yan, partial derivative of u or second partial derivative of u with respect to x plus second partial derivative of u with respect to y equals 0. Ito din, yan, partial derivative. And as you can see, natutunan natin yan sa differential calculus, magkaiba yung notation ng ordinary differential equation tsaka ordinary derivative sa partial derivative. Yung partial derivative medyo mas malandi siya. At diba kapag partial derivative, kaya siya tinawag na partial, i-derive mo lang siya kung saan ay ang isang differential equation by order. And by order, we mean, yung order ng isang differential equation is yung pinakamataas na derivative nung equation mismo. Okay, titignan mo lang kung dun sa equation kung nasaan ang may pinakamataas na derivative. Okay. For example dito, this is a second order differential equation kasi ang highest derivative is ito. Okay? Itong 3 dito, that is just the exponent of the first derivative. Okay, so itong part na to is first order. Yung 3 is actually tinatawag din siyang kadalasang degree or yung exponent niya. So hindi siya yung pinakamataas na order kasi first derivative ka lang. Ito yung second derivative. Yan. So itong equation na to, ang order niya ay 2 or second order differential equation. Kasi nga yung 2 or yung pinakamataas na derivative ay second derivative. Okay. Marami tayo kasing no, sana nalinaw yan sa notation natin sa differential calculus pa lang. No, yung ginagamit natin na itong mga dy dx, yan, ang tawag natin doon is Leibniz. Minsan may T si Leibniz, hindi ko rin alam kung ano bang tamang spelling ni Leibniz. Minsan may T dito eh. O Leibniz. Yan. Ito yung dy dx. Yan. Leibniz notation. Kasi marami, as you can recall, nung pinag-aralan nyo yung differential calculus, maraming notation. Kasi si Leibniz at si Newton, sabay nilang na-discover yan. Actually, nagtatalo pa nga sila, diba? Kung sino ang naunang nakadiscover. And magkaiba sila ng notation. So, ito, kay Leibniz, ganyan yung notation na. Which is, ito yung karaniwang ginagamit natin. Kasi, madali siyang maintindihan. Kasi, dito, alam mo na kaagad na si y, siya yung independent variable or siya yung nag-change with respect to the independent variable. Wherein, dun sa ibang notation, hindi natin alam kung sino ang dependent and independent. And alam din natin, ginagamit din natin yung prime notation. Diba? Yung prime notation, yung gumagamit tayo ng prime, y prime, yun yung equivalent ng dy all over dx. Pag y double prime, ibig sabihin, second derivative of y with respect to dx, and kapag triple prime, or third derivative ng y with respect to dx. Ngayon, kung mas mataas dyan, hindi mo na pwedeng lagyan ng iba pang, ng dagdagan ng prime. Pag mas mataas na sa 3, i-exponent mo na siya, pero, to distinguish lang na derivative yung ibig sabihin natin at hindi lang yung exponent siya, is lalagyan natin siya ng parenthesis. Ang ibig sabihin nito, fourth derivative. Kailangan meron siyang parenthesis kasi kung ganyan lang siya, ibig sabihin lang yan, exponent ng si 4, y raised to 4 lang yung ibig sabihin niya. So, para malinaw tayo, ang y raised to 4, ang ibig sabihin niyan, fourth derivative of y with respect to x. And so on kung meron pang y. Y raised to n, para ma-generalize lang, is kailangan may parenthesis, nth derivative of y with respect to x. Ito, ginagamit din natin. So, depende kasi sa problem na pag nakita nyo. So, mahalaga na alam na natin yung mga notation na yan kahit anong gamitin o kahit anong lumabas sa problem. Actually, meron pang dot notation. Merong dot notation, meron pa tayong tinatawag na subscript notation. Sa dot notation, ang second derivative lang, for example, yung sa projectile or sa gravity, ayan. Sa dot notation ni Newton, pag second derivative, lalagyan niya ng dalawang dot. Ayan, sa may taas ng S. Pag isa lang yung dot, first derivative. Pag dalawa, second derivative. So, equal sa negative 32. Yan yung sa gravity, diba? 32.2. Sa subscript, ginagamit, sa subscript, ibig sabihin nasa ibaba. Pag ganito, ibig sabihin nito, dalawang second derivative of u equals second derivative of u with respect to t minus O yan, 2 times the first derivative of u with respect to t. Yan, naman yung subscript. Nasa subscript naman. So, pero kadalasan ang gagamitin natin dito, mas madali kasi si Leibniz or si prime notation. Pwede rin natin ma-classify ang isang differential equation by linearity. Okay. By the way, balikan ko lang to, dun sa order. May mga iba pang ways kasi ng pagsusulat ng isang differential equation. Sorry, na-skip ko siya. So, yung iba, burahin ko na. Prime. Nire-rewrite nila sa a function notation. Kagaya ng ito. F, X, Y, Y prime, hanggang sa kung ilan mang derivative yan, equals 0. Yan, ibig sabihin lang nito, meron kang function na function ng X, Y, Y prime, at kung pang ilang derivative. No? Kapag ganito yan, f of x, y, ibig sabihin, meron kang function na function lang ng variables x and y. Yun po. And kadalasan, sinusulat din sa tinatawag nating normal form. Yung normal form is yung pinaka-highest derivative ay nilalagay dito. So, y raised to n or pwedeng f derivative of y. And then, yung mga susunod na is nire-rewrite na as a function. Pero, minus 1 na lang. Kasi nandito na yung highest derivative na n. So, yung nasa kabilang side, yun na yung hanggang n minus 1 na lang yung order or function ni xy hanggang n minus 1 derivative ng function. Example nito, in normal form yan. Y double prime equals y prime plus y minus 6. Yan. Normal form yan. Kasi nandito lahat. Nasa left side, yung highest order derivative or highest derivative. And then, as a function, nakasulat siya explicitly as a function of the other derivatives na mas mababa sa kanya. Yan po yung tinatawag nating normal form. And then yun nga, pwede natin maklasify as linear or non-linear ang isang differential equation. Pag sinabi nating linear, kung i-rewrite natin siya as a function of y, y prime, y double prime hanggang nth derivative of y, para matawag na linear, dapat ganito yung form niya. Where, sabi niyo, sir, nakakalula. Hindi. Ang ibig sabihin lang nito, lahat, papansinin niyo, lahat ng may derivative, ang degree niya ay 1 lang. First degree derivative. Ibig sabihin, wala silang exponent. No? Tapos yung mga a0, a1, yan yung mga coefficients niya, which could be a function of x. Sorry, dapat may function of x yan. Function of x. Para matawag na linear. Di ba parang dun sa line, definition natin ng line, kunwari x plus y equals 5. Di ba line yung representation yan? At kung mapapansin nyo, linear siya kasi yung degree ng bawat variable ay 1. 1, 1. Ganun din sa linear differential equation. Dapat yung degree or exponent ng bawat derivative ay 1. Kung may nakita ka na hindi 1 or may ibang exponent, 2, 3, 4, gano'n, naka-squared, naka-cube, hindi na yon linear. Non-linear na yon. Yan. Dito, merong mga dalawang common, which is pag-aaralan natin, na types ng linear differential equation. Meron tayong ito, first order linear differential equation. Tinatawag din siyang FOLDE, first order linear differential equation. FOLDE. First order siya kasi ang highest degree niya is 1. And then, parang mali ito. Dapat hindi ito derivative. Dapat y lang yan. Dito, ito yung dulo ito. Yung dulo niyan, dapat y lang yan. First order kasi ang highest derivative ay 1. Tapos linear siya kasi yung mga exponent ng mga derivative na yon ay 1. Meron din tayong tinatawag na second order linear differential equation, SOLDE. Second order, highest derivative ay 2, tapos linear sila. Yun no, ang exponent nila ay 1. Again, y ito. Ano ang itsura, sir, ng mga nonlinear? So, hindi lang kasi ang mga nonlinear, hindi lang yung mga derivative or differential equation na may derivative na ibang exponent. Pwede rin siyang yung mga trigonometric functions. Ganun. So ito, this is a nonlinear kasi at a glance, sir, bakit naka-degree 1 naman yung iba? Pero tignan mo, naka-multiply ito. Ibig sabihin, second degree yan. Sorry. Tama, second degree. No, second degree, ibig sabihin, yung, hindi na siya non-linear kasi dapat ang degree ay 1 para maging linear. Walang pinagkaiba yan sa y, tapos minultiply mo ng y squared. Hindi na yan linear kasi exponent niya na ay 2. Pwede rin ito.
Sir, derivative ba yung y?
Ito, although, yung parang example, although ito ay second order, na ang degree niya ay 1, meron siyang kasama kasi na sign. Alam niyo naman ang sign, non-linear yan. So, magiging non-linear pa rin yung sagot natin. Ito, yung highest order niya, ang degree niya ay 1, pero yung variable na y squared, hindi yan linear. So, non-linear pa rin siya. Basta't may nakita kayo kahit isang term man dyan na magiging hindi linear or non-linear, yung buong equation matatawag na nating non-linear differential equation. Okay? Ano naman ang solution? Kasi equation yan, sir. Anong pinag-aaralan natin? Actually, ang hinahanap natin dito sa mga differential equation is yung solution. So, umpisahan natin sa solution ng isang ordinary differential equation. ODE muna tayo. So, saka na muna yung partial derivative or differential equation. Yung solution ng isang differential equation is actually a function. Merong interval, kailangan natin i-define yung interval na yon, dapat continuous siya. And alam niyo na, pag sinabi natin continuous, differentiable, nadi-differentiate. Which, when substituted into an nth order differential equation, reduces the equation to an identity, is said to be a solution. Para maging solution, for a function to be a solution of a differential equation, dapat pag sinubstitute ko yung function na yon, magiging identity or masosolve niya yung differential equation. Magiging identity yung kalalabasan. Okay? Importante dito yung interval. Okay? Paki-take note, kailangan laging may interval. Okay? Sinasabi natin yan. Pero kadalasan from negative infinity to infinity yan. Pero not all the time. Yung solution mo, dapat within the interval, masasagot niya or ma-reduce to identity niya yung differential equation. Paano ba yan? Ayan, mag-example tayo para maintindihan. Verify daw natin na yung indicated function is a solution of the given differential equation on the interval, baliktad, sorry, negative infinity to infinity. Sorry po, sorry, typo. Okay, i-verify lang natin. Ibig sabihin itong function na to, malamang baka malito pa kayo. Sir, nasaan dyan ang solution at nasaan dyan yung differential equation? Malamang yung differential equation yung may derivative. So, ito yung DE niya. Ito yung sinasabi nilang solution. So, ipoprove natin, verify kung tama ba. So, paano yun ipoprove? Kopyahin ko lang sa next page. So, ito yung differential equation, dy over dx equals xy raised to 1/2, or that is square root of y. Yung sinasabing solution is y equals 1 over 16 x raised to 4. Ayan. Ang ibig sabihin nitong dy over dx is first derivative ng y with respect to x, diba? Pero ano ba yung y dun sa given solution? Y equals 1 over 16 x raised to 4. So, ano ang dy over dx? De-derive lang natin to. Diba? Kayang-kaya nyo yan. So, power rule lang yan. 4 over 16, or that is 1/4 x raised to 3. Yan yung kinahihinatnan nung left side. Tingnan natin dun sa right side, gamit yung solution pa rin kung parehas ba. So that is x times y raised to 1/2. But what is y? Again, yung solution. So, substitute lang natin, 1 all over 16 x raised to 4, and then meron siyang exponent na 1/2. That is x. I-simplify lang natin. 1 all over 16 raised to 1/2, di ba? Naka-product yung dalawang yan, loss of exponent, pwedeng tig-isa sila ng exponent. Ngayon, itong x raised to 4 raised to 1/2, power of a power ng loss of exponent. Pag mumultiplyan natin silang dalawa, 4 times 1/2, that is x squared. And then, loss of exponent din nito, di ba ang raised to 1/2 is actually square root. So, ang square root ng 1 is just 1. Square root ng 16 sa baba is 4. And then ito, x raised to 4 raised to 1/2 is x squared. Simplify, we have 1/4 x cubed. See, parehas siya dun sa kabila. Ibig sabihin, meron na tayong identity. Ibig sabihin nito, parehas yung kanan tsaka yung kabila kapag sinubstitute natin. And therefore, dahil na-verify mo na tama, na-satisfy niya yung equation, and then therefore, yung y equals 1 over 16 x raised to 4 is a solution. Okay? Take note, yung ginamit kong article is a, hindi is the. Kasi ang differential equation ay pwedeng maraming solutions. No. I'll just give you an example. Balikan nyo yung integral calculus nyo. Pag nag-integrate tayo, indefinite integral, x dx. Anong sagot natin dito? Power rule, x squared all over 2 plus an arbitrary constant, c. Anong ibig sabihin nito? Sabi natin, hanggat hindi natin nilalagyan ng definite interval kung saan tayo nag-i-integrate, pwedeng kahit ano ang ibig sabihin ng c. Ibig sabihin, there are infinitely many solutions. At ganoon din sa differential equation. Hanggat hindi mo binibigyan ng value or ng specific interval, hindi magiging isa yung solution mo. And for this example, y equals 1 all over 16, x raised to 4 it is just one solution. Marami pang pwedeng solution dyan. And soon, matututunan natin kung paano hanapin yung lahat ng solution. Ito pa, isa pang example. I-verify ulit natin that ito, y equals x e raised to x. Baliktad na naman yung interval ko. Is a solution of y double prime minus 2y prime plus y equals 0. Kopyahin ko lang Again, y double prime minus 2y prime plus y equals 0. And then, ang solution daw niya is x e raised to x. Hanapin natin yung first derivative. This is a derivative of a product. Sana naalala nyo pa, anong derivative ng product? U dv plus v du. Ang u natin, x. Ang e raised to x, v. So, u, ano ang derivative ng e raised to x? It is just e raised to x. Tapos, i-derive mo yung exponent niya. Pero, ang derivative naman ng x ay 1. So, okay lang. Huwag na natin ilagay. Plus v, that is e raised to x, and du. What is the derivative of u? Derivative of x is 1. So, wag na natin ilagay. Next, kunin ko yung y double prime. Bakit ko kinukuha? Kasi yun yung nandito Diba, to verify, isosolve ko dapat. Kasi yun yung aim Para ma-verify mo, ma-prove mo na solution siya, dapat pag sinubstitute ko tong mga to, lalo na ito, mag-i-equal yung dalawang side ng equation or magkakaroon tayo ng identity. So, i-derive ulit natin. Paano kunin yung second derivative or y double prime? I-derive mo yung first derivative or y prime. So, again, itong x e raised to x, it is just the same as the derivative of y. So, kukopyahin mo lang din yan. Ayan. Ito ay yung derivative niyan. Pero kailangan mo pang i-derive ito. Okay? So, plus, ano ang derivative ng e raised to x? E raised to x lang din times 1, or that is e raised to x. Simplify ko lang, that is equal to x e raised to x plus 2 e raised to x. Pwede na ako mag-substitute kasi nandito na yung mga kailangan ko. Y double prime, x e raised to x plus 2 e raised to x. Ito yan, second derivative of y or y double prime minus 2 times first derivative, ito, x e raised to x plus e raised to x plus y, ito mismo. So, x e raised to x, dapat mag-equate sa 0. Wala ka namang substitute sa kabila, no? Nag-0 lang siya. So, titignan mo lang kung kailan siya mag-0. Ayan. Simplify. X e raised to x plus 2 e raised to x. I-distribute natin ang negative 2. So, negative 2x e raised to x minus 2 e raised to x plus x e raised to x equals 0. Combine like terms. Ito, isang x e raised to x, isang x e raised to x. That is dalawang x e raised to x, pero may negative dito, so 0 na yon. Positive 2 e raised to x minus 2 e raised to x, 0 din. So, 0 equals 0. Check. Na-prove mo again, meron kang identity, and therefore, verified and proven, yung y equals x e raised to x is a solution of the differential equation na ito. Ganun na siya. So, sa ngayon, hindi pa natin alam paano nakukuha ito kasi given naman siya kaagad, bine-verify lang natin. Sabi natin kanina, di ba, a solution is a function na merong given interval na kapag sinubstitute ko sa differential equation, masasatisfy o magkakaroon tayo ng identity. Since function siya, Solution is also a curve. Ibig sabihin, pwede natin siyang i-graph. So, yung graph ng solution natin na phi or phi ng ordinary differential equation, yun yung tinatawag nating solution curve. Pero, okay, I'll just give you, magkaiba kasi yung, for example, pwede nating sabihin that y equals e raised to x is a function. Pero pwede rin that y equals 1 all over x is a solution. So, ano ang distinction nilang dalawa? Dun papasok yung interval. Kaya ko sinabi na importante yung interval kanina. Okay? Di ba yung y equals 1 over x, kapag rinaf natin yan, ganyan yan. Parabola yan eh. Defined siya for all values of x except ano? X equals 0. Kasi at x equals 0, of course, infinite yan. Other than that, defined yung function natin. Pero para maging solution siya, actually, si y equals 1 over x is a solution of x, y prime plus y equals 0 na differential equation. However, hindi sila parehas ng interval. Para maging solution si y equals 1 over x ng x, y prime plus y equals 0, ang interval natin is mamimili ka. So, pwedeng dito, pwede ring dito. Depende sa interval. Pero hindi mo dapat isasama yung values ng x na hindi siya defined. Kasi at x equals 0, again, may discontinuity na tinatawag. Di ba? Wala siyang value at x equals 0. And sabi natin kanina, dapat continuous yung function. Dapat differentiable. Kung hindi continuous, hindi differentiable, kung may discontinuity, hindi mo matatawag na solution yon. So, specific tayo. So, ang distinction lang ng dalawa, no, yung function na y equals 1 over x at yung solution na y equals 1 over x is just the interval. Kaya, napaka-importante na sinasabi natin, saang interval ka? Kailangan sabihin mo yun explicitly. Okay, and going back dun sa sinabi ko na hindi lang pwedeng iisa or hindi iisa ang solution ng isang ordinary differential equation kasi meron tayong tinatawag na family of solutions. 'Di ba yung meron tayong arbitrary constant c doon sa integral calculus na kung saan kahit sino or kahit anong value ni c pwede. Ibig sabihin hindi lang isang solution, meron tayong tinatawag na family. And because a solution is a curve or solution curve, tinatawag din siyang minsan family of curves. Yan yung other term niya. Sabihin lang nito, maraming pwedeng solution. A family of solutions or family of curve is a set of solutions. It is a solution containing arbitrary constants representing the set of solution. Yung arbitrary constant na yun yung C sa integral calculus. Sa integral calculus pero, isang C lang yung ginagamit natin, di ba? Plus C lang lagi. However, in differential equation, arbitrary constants. Pwedeng more than one yung constants natin. Actually, makikita natin merong C1, C2, soon sa mga problems, C3, kahit ilan. Pwede. And each arbitrary constant actually, yun yung mga hinahanapan natin ng solution. Marami rin siyang pwedeng, kagaya ng isang arbitrary constant na C sa integral calculus, marami din siyang pwedeng values. Okay, dito, make example tayo. Verify that the functions x equals c1 cosine 40 and x equals c2 sine of 40, where c1 and c2 are arbitrary constants, are both solutions of the linear differential equation x double prime plus 16x. I-verify lang natin. Okay, yung given na differential equation is x double prime 16x equals 0. No, hindi kayo sanay. Parang hindi kayo sanay. Sir, bakit si x ngayon ang may derivative? Di ba laging y lang, y prime? No, again, hindi, variables lang naman yan. As you can see dito, si x ang independent variable, tapos si x ang dependent variable, si t ngayon yung independent variable. Ang solutions niya daw, pabalik-balik ako, x equals c1 cosine of 4t and x equals c2 sine of 4t. Tama ba? Ayan. Okay, unahin natin itong c1 cosine 4t. Kailangan ko ng double prime. So, when x equals c1 cosine of 4t, derive ko siya, x prime with respect to t is c1, anong derivative ng cosine, times negative sine of 4t, chain rule, i-derive mo pa yung nasa loob, derivative of 4t is 4. So, x prime is negative 4 c1 sine of 4t. Kailangan ko double prime. So, x double prime equals, derive ko ulit yung first derivative. Negative 4 c1 times derivative of sine 4t is positive cosine 4t. Chain rule again, i-derive mo pa yung nasa loob. Derivative of 4t is 4. And that gives us negative 4c1 times 4, negative 16 c1 cosine 40. Substitute nga natin kung tama ba na meron ba tayong identity. Negative 16 c1 cosine of 40 plus 16 times ano ang x? c1 cosine of 40 equals 0. Ngayon pa lang nakikita nyo na magzi-0 talaga siya. Yan. Tama. So, si x, c1 cosine 40 is a solution. How about the other one? Shortcut na natin. Ang x prime ay 4c2 sine 40. X double prime ay negative 16 c2 cosine 40. At pag sinubstitute natin yan, cosine pala to, cosine. Derivative ng sine, cosine. Tapos ito magiging sine. So, pag sinubstitute nyo yan, negative 16 c2 sine of 40 plus 16 c2 sine of 40 equals 0. Again, 0 equals 0. See? Dito pa lang, dalawa na yung solution. Kasi nga pwedeng marami, family of solutions. And actually, kahit anong value ni c as a constant at c1 at c2, pwede pa. Ngayon, kung gusto nating specify lang, kung saang interval lang yung kukunin natin, kasi maraming solution, di ba? Family of curves nga. Pero kung meron lang tayong gustong kunin, ang tawag natin dun is particular solution. At ang gagawin mo lang para ma-solve ang particular solution is to eliminate the arbitrary constant, because a particular solution is a solution of a differential equation na walang arbitrary parameters or arbitrary constant. Free of arbitrary parameters. Walang C1, walang C2. Specified siya. Analogous to integral calculus. Diba, nung nag-indefinite integral tayo, ang sagot natin is x squared all over 2 plus c. And I've already told you infinitely many values ang solution nito kasi pwedeng maraming values si C. However, kapag nag-define tayo ng interval or sub-interval within the interval of x dx or integral of x dx, kunwari from 1 to 2, na-eliminate yung arbitrary constant na C. Tama? Anong nangyayari? Nagiging definite integral tayo. Ayan. Dinirekta ko na. 2 plus 1 half, minus 1 half. 2 minus 1 half, 3.5. Ayan, wala ng C. Yung sagot natin sa definite integral, wala ng C. Sa indefinite integral, may C. Ganun yon. This is the family of solution or tinatawag din siyang, yung family of solution or family of curve ay tinatawag ding general solution kasi ito yung generalized solution. Sakop niya lahat. Once we define a particular or a specific interval, nawawalang arbitrary constant, nagkakaroon tayo ng particular solution. Example, verify muna natin si y equals x raised to 4 is one parameter family of solutions of the differential equation xy prime minus 4y equals 0 on the interval negative infinity to infinity. The differential equation is x y prime minus 4y equals 0. At yung solution na sinasabi is y equals cx raised to 4. Kailangan ko ng y prime, so i-derive ko siya. 4cx cubed. Substitute natin x times 4cx cubed minus 4 times cx raised to 4 equals 0. So 4c x raised to 4 minus 4c x raised to 4 equals 0. Therefore, 0 equals 0. So, itong solution curve na, itong family of solutions na y equals c equals x raised to 4 ay solution. Pero may mga solution na hindi kabilang dito. Okay, for example, y equals negative x raised to 4. Is that a solution? Try natin. Ang y prime natin is negative 4x cubed. So, x times, substitute ko dun sa mismong differential equation, negative 4x cubed minus 4 times negative x raised to 4 equals 0. Negative 4x raised to 4 plus 4x raised to 4. Pasok pala siya. Pero hindi sila parehas ng interval. Kapag rinamp natin itong y equals cx raised to 4, for example, for c equals 1, ang itsura niya is ganyan. Ito yung c equals 1, tapos ito naman yung c equals negative 1. So, when c equals 1 and c equals negative 1, masosolve pa rin natin yung, it is still a solution. So, nagiging particular solution siya. Yung y equals x raised to 4 and y equals negative x raised to 4 are particular solutions ng differential equation kasi wala na siyang arbitrary constants. Pwede mo rin palitan ng 2, ng 3, ng 4, kahit ano. At hindi lang siya basta function, pwede rin siyang piecewise. For example, kung gusto mo lang kunin dyan, kunwari sa dito sa graph na to is yung ito lang at saka ito. Ayan. C equals 1, ito C equals negative 1. So, gagawin mo siyang piecewise function. Pwedeng y equals negative x raised to 4 for x less than 0, di ba? Kasi nandito sa left side, ito, nasa baba siya. And positive x raised to 4 for x greater than or equal to 0 or greater than 0. Yan. Again, this is still a particular solution. At ang tawag natin dyan mga piecewise. Pag sinabi mong piecewise, napuputol siya. Mayroong discontinuity. Okay. Meron siyang discontinuity at x equals 0. So, these are particular solutions nung differential equation natin. Ang general solution niya ito. Meron siyang arbitrary constant c. Kung gusto mong maging particular, magke-create ka or magagamit ka ng values of c. So, depende sa'yo or depende sa problem kung saan niya in-specify na saang interval mo siya kukunin. So, meron pa akong ibang example. Tingnan natin. Mamaya. Ano ngayon ang initial value problem? Mamaya makikita natin yung ibang example ng particular solution. Lalo na dito sa initial value problem. Ang initial value problem ay may problem na ito, differential equation siya, isosolve natin siya, pero meron tayong constraints. Ito yung mga constraints na tinatawag. Huwag kayong malulula. Ang ibig sabihin lang naman yan is, actually, mga yan given yan. So, makakatulong yan para ma-solve natin yung initial value problem. Meron kang differential equation. Bukod doon, sa differential equation, meron kang mga kondisyon na dapat masatisfy. Yan yung mga example. Pwedeng y prime of 0 dapat 1, y prime of 2 dapat 0, ganyan. Kasi kung ito lang, general solution yan. Again, sabi ko nga, maraming pwedeng solution. Pero kung gusto mong i-specify, kung gusto mong particular solution, mag-specify ka. So, yung initial value problem, ganun yung ginagawa natin. Example, verify that one parameter family y equals c e raised to x is a one parameter family of solutions ng simple first order differential equation y prime equals y, wala ito, on the interval negative infinity to infinity. Y prime equals y at ang sinasabi niyang solution is ayan. Kunin natin muna yung general solution. Y prime equals ano ang derivative ng c e raised to x? That is just the same as c e raised to x. Diba? And therefore, pag sinubstitute natin, na-prove natin kaagad, verified that y equals c e raised to x is a solution, is a general solution of the differential equation y prime equals y. Next, kung sakaling nag-create tayo, nag-impose tayo ng initial condition, this is a continuation ng problem. Kung sakaling in-impose natin that y of 0 equals 3, ano ngayon ang solution ng differential equation? Since sabi natin y equals c e raised to x, and since y0 equals 3, ang ibig sabihin ng y of 0 equals 3 is dadaan dapat itong curve mo or itong solution mo sa point na 0, 3. So, wala tong pinagkaiba dun sa f of x equals 3 or f of 0 equals 3. So, kapag ginawa mong when x equals 0, y equals 3. Yun yung ibig sabihin ng y of 0. So, dadaan siya dapat sa 0, 3 or x equals 0, y equals 3. Therefore, isa-substitute mo lang yung 0, 3 dito. So, 3 equals c times e raised to 0. E raised to 0 is 1. So, 1 times c is c. And therefore, c equals 3. Pag nakuha mo ngayon yung value of c, isa-substitute mo siya doon para maging particular solution siya ng initial value problem. Kasi 'di ba, initial value problem may constraints, ang makukuha mo ay particular solution. Si particular solution, dapat wala siyang arbitrary constants or mga c. Para mawala yon, yung nakuha mong value ni c, isa-substitute mo sa general solution. So dito, magiging y equals, ano si c? 3 e raised to x. Paano natin nakuha yung value na c? Kasi in-impose natin yung initial condition or na initial values. Ito ngayon, y equals 3 raised to x. This is the solution. Specifically, particular solution nung initial value problem. Automatic naman yun. Pag sinabi mong initial value problem, particular solution yung nakukuha mo. No, hindi siya general solution. Kasi nga may initial conditions na pwedeng gamitin. Okay. Sabi naman niya, what if we demand that the solution curve pass through the point 1, negative 2, ano na yung magiging solution? Same step. Ito yung general solution. I-substitute mo kung saan siya dadaang point. 1, negative 2 is the same way as saying of y of 1 equals negative 2. So, substitute mo lang, ito si x, ito si y. So, negative 2 equals c e raised to 1. Oh, hindi na-cancel si e. Ibig sabihin yan, e raised to 1 is the same as e, di ba? So, solving for c, we have negative 2 divided by e. Substitute mo ngayon yan dito. So, ang mangyayari, y equals, substitute c, negative 2 all over e raised to x. Bakit hindi ko sinimplify ito, sir? Kasi constant naman si e, pag nilagay mo yan sa calculator, may masasolve ka. Para lang maging eksakto yung sagot natin. Kasi, di ba, you can rewrite this as negative 2 e raised to x all over e. Or, same base ito, na e, nasa baba si e raised to 1, so magiging negative 2 e raised to x minus 1. Kasi same base sila, so pwede nating pagsamahin loss of exponent. Isang exponent lang sila, pero dahil nasa baba yung isang e, negative 1 siya. Yan. So, ito na yung solution ng ating, sorry, dapat may y yan. Ayan, dapat kasama yung y. Ito na po yung solution ng ating initial value problem. Maraming pwedeng maging solution, depende dun sa initial conditions na sinasabi niya. Kasi nga, on the first phase, general solutions, infinitely many. Pinipili lang natin, depende sa mga condition na gusto natin, sa interval tayo. Pag enough natin yan, ganito yung magiging itsura. No, itong lahat ng to, actually, this is just a part, maraming, itong yung curve na blue at red, yan yung general solutions. Graph ng general solutions for any value ng c. Pinili natin ngayon yung for the first part when y of 0 equals 3. Ito yung solution na yon, yung nasa gitna. Yung mas dark ang font or basta yung mas dark dyan na blue, yun yung solution na tumugma dun sa initial condition natin or na nag-pass through 0, 3. Dun sa pangalawang initial condition, 1, negative 2, yung nasa baba naman. So, pinipili lang natin dahil sobrang dami. Pipiliin lang natin kung ano yung kakailanganin. Okay. Let's try another example. Number 5. Verify that the one parameter family y equals 1 all over x squared plus c is one parameter family of solutions of the first order differential equation y prime plus 2xy squared equals 0. Again, ibig sabihin ng verify, substitute lang natin. Y prime plus 2xy squared equals 0. Y equals 1 all over x squared plus c. Ito yung bine-verify natin, no? Kailangan lang natin ng y prime. So, y prime, anong derivative nito? 1 all over x squared plus c. I-rewrite mo siya as x squared plus c raised to negative 1. So, pag dinerive mo siya, negative 1 times x squared plus c. Tagalin ko na yung 1 So, negative, kasi negative 1 yun. Then, si negative 1, mamaminosan pa siya ng 1, power rule, so negative 2. Tapos, i-derive mo pa yung nasa loob, x squared plus c. So, 2x. Ang derivative na c ay constant, so ang derivative niya is just 0. Or, i-rewrite natin, y prime is negative 2x times x squared plus c raised to negative 2. Substitute natin po rito. Y prime is negative 2x times x squared plus c plus 2x times y squared raised to negative 2 ito. X squared plus c raised to squared yun, negative 1 tapos i-square pa. So, very obvious naman na magzi-zero yan, no? Pero sige, ituloy na lang natin. Power of a power, x squared plus c raised to negative 2 equals 0. Positive, negative, cancel. So, verified. This general solution is a solution. It's actually the solution na pala of y prime plus 2xy squared equals 0. May follow-up condition yan. If we impose an initial condition y of 0 equals negative 1, determine the solution. So, yung general solution, para makuha yung solution sa initial value problem, i-substitute mo lang ito. This means, y of 0 equals negative 1. Ibig sabihin yan, x equals 0, y is negative 1. So, that is negative 1 equals 1 all over 0 squared is still 0, and that is equal to c, or 1 all over c, or c equals 1 over negative 1 or negative 1. Substitute mo yung nakuha mong value ni c, y equals 1 all over x squared minus 1. This is the particular solution or the solution of the initial value problem. Yan, pag enough natin yung ito yung function defined for all except meron siyang discontinuity kapag function lang siya. Ngayon, ang kinukuhanan lang natin is yung function na dadaan sa 0, negative 1. And therefore, yung red part lang, ito lang, yun yung solution ng ating initial value problem. Kung sakaling dito tayo kumukuha, syempre may iiba yung initial value natin dyan. No? Pag sinabi nating initial value problem, as you can see, masasatisfy niya dapat yung dadaan dapat yung curve doon. Diba, nakikita nyo ba yung mga pinakita kong graph, lahat ng binigay na initial value problem, lahat yun, dinaanan. Ayan o, kagaya nito, dinaanan niya mismo. Doon mismo dumaan yung solution or yung solution curve natin. So, yun yung ibig sabihin ng initial value problem. Kasi dapat masatisfy. So, dadaan talaga siya sa curve. So, dito sa differential equation, kung bakit siya tinawag na language of the universe, kung ilan, it's because na-explain niya ang several phenomena and using a mathematical model, pwede nating malaman yung magiging kahihinatnan or state ng system natin. Anong ba ang mathematical model? Pag sinabi mong mathematical model, modelo, yun yung description ng isang system of phenomena. Yun yung sinusundan. Model nga, di ba? Mathematical model. Yun yung sinusundan ng isang system in terms of mathematics. For example, yung gravity, or how the projectile works. Diba? That is the second derivative of distance with respect to time is always a certain constant g, which is equal to 9.81 or negative 9.81 or negative 32.2 kapag feet per second squared, meter per second squared. Yan. Ito yung model ng projectile. Ibig sabihin, any point in the projectile, sinusunod niya ito kasi siya nga yung mathematical model. And when we say mathematical model, we actually mean differential equation. Kasi sa physics and engineering, halos lahat ng phenomenon ay merong rate of change. And by our study of differential calculus, rate of change is actually the derivative of a certain function or something. And ano nga ba yung dinefine natin kanina na definition ng differential equation? A differential equation is an equation that contains derivatives. So, when we say mathematical model, we actually mean we are looking for a differential equation. And para ma-model mo yung phenomenon, you look for solution of this differential equation. And the solution of the differential equation will actually give you the state of the system. Ibig sabihin, kapag resolve mo yung differential equation na yon ay nababase dun sa variables or mga aspects or factors considered dun sa system, especially yung mga variables na nagbabago. Pag na-solve mo yung differential equation na yon, siya na yung model mo. Ibig sabihin, makikita mo na yung past, present, and future nung system na yon. Mahuhulaan mo na, masusundan mo na, maprepredict mo na using your model kung ano ang kakahinatnan ng system mo. And dito pa lang, makikita na natin na sobrang dami ng application ng differential equation. And to give you just a few, ito yung mga yon. Population growth is one of the common example ng differential equation. Nalalaman natin gaano kabilis lumaki ang population. And by population, hindi lang siya sa tao, no? Pwede ring sa bacteria, bacterial growth, gaano kabilis dumami. Usually, differential equation yan is the change in population is directly proportional to the present population. Siyempre, kung mas maraming tao, mas mabilis silang dumami. So, eliminate mo yung proportionality constant, papalitan mo lang ng Kp. And ito na yung isa-solve mo. This is a general solution, differential equation. Isa-solve mo siya. Pero simple lang to, no? Walang ibang parameters. Kasi pwedeng may ibang factors dyan. And idadagdag mo yan. Minus mu of t. Yan. Mga iba't ibang parameters. Pero kung nagsisimula ka pa lang, Hindi naman masyadong required, negligible naman, pwede mo siyang tanggalin. Kung mapapansin nyo, nung nag-aaral tayo ng project tayo sa physics, anong lagi nating nine-neglect? Air friction. Diba? Lagi nating tinatanggal yung air friction. That is actually, kasi pag may air friction, it will complicate matter. No? Kasi that is another parameter. And kapag another parameter yan, another constant, arbitrary constant, mas magugulo yung differential equation natin. So, para maging simple, ninineglect natin yon. Bukod sa population growth or population dynamics, sa radioactive decay, half-life, gaano kabilis nag-decay ang isang radioactive material, that is another common application of differential equation. Newton's law of cooling or warming, gaano kabilis uminit o lumamig ang isang material. No, actually, the change in temperature of a material with respect to time is directly proportional to the difference of the temperature of the body, kung gaano kainit yung mismo body, minus yung ambient temperature or yung temperature ng surrounding environment. Kaya napapansin nyo, proven naman to logically at saka ng physics, kung mainit yung environment, anong nangyayari sa'yo? Umiinit ka din, di ba? You feel the heat. Pag malamig, nilalamig ka din. Kasi ganun nga yung Newton's law of cooling. And by Newton's law of cooling, malalaman natin kung gaano kabilis o kabagal lumamig o uminit ang isang bagay. Marami itong application. For example, ang application nito sa forensics, malalaman natin kung gaano, nalalaman ng sino na yun sa SWAT team or ng ano na yun sa Pilipinas, nalalaman ng SOCO ng mga pulis, gano'n na katagal namatay yung bangkay, depende lang sa temperature. Kasi lalamig yun, di ba? Pag namatay, lalamig. So, alam nila, pwede nilang gamitin ang Newton's law of cooling or warming para malaman ilang hours na, given yung temperature and other factors, yung temperature ng environment. Pwede rin yung spread of disease, chemical reactions, mixture. Pag naghalo tayo ng shembot, de joke. Naghalo ka ng brine solution, ganon. Gaano kabilis nagbe-brain yung tank? Ito, Torricelli's law. Series circuits, kung kayo ay ECE, pero civil ata kayo. Kirchhoff's law, current law sa electronics. Itong draining na tank, pwede sa inyo, fluid mechanics yan. Falling bodies and air resistance sa physics, na pag-aaralan na natin yan. One day, i-derive ko, paano natin nakuha yung Tito, Vic, and Joey gamit ang differential equation. And suspended cables, ito, pasok sa inyong mga civil engineers. So, these are just few of the examples or applications or field or natural phenomena na ginagamitan ng differential equations. Napakarami. Almost everything that involves rate of change, pwede mong gamitan ng differential equation, pwede mong hanapan or gawan ng mathematical model para ma-predict mo at ma-study mo ano ang behavior ng system. So that is all for the introduction to differential equations. Any question?